Now we're talking about removing perfect square factors from underneath the radical sign. And specifically, we're talking about simplifying the results of an operation like this. Suppose we're multiplying two radical expressions together and we need to simplify the result. When we're simplifying the result, one of the things we need to do is remove any perfect square factors from under the radical sign. So take a look at this. 4 root 3 times 2 root 6. Now the square root of 3 is simplified. There aren't any factors of 3 that are perfect squares that we can bring out from under the radical. And the same is true with the square root of 6. There are no perfect square factors of 6. But when we multiply these together, the 4 and the 2 get multiplied and we get an 8. And then the square root of 3 and the square root of 6 get multiplied and we get a square root of 18. So this is the result of multiplying these two radical expressions. We get 8 square root of 18. Now the square root of 18 does have a perfect square factor. This could be written as 8 times the square root of 9 times 2. 18 is just 9 times 2. And the 9, you see, is a perfect square. So in other words, the square root of 9, I think of that as a 3 instead. So I imagine this 9 popping out here and becoming a 3. It gets square rooted, and so I have a 3 times 8 right there, which is 24. And 24 times the square root of 2 is the answer. Now this is considered simplified, not this. And the reason is, as long as there's a perfect square factor in there, and specifically we have the 9, it can and should be brought out front, brought outside of the radical, and that's what gave us the 24 out front. So 24 square root of 2 is the answer. Here's another example. The square root of 12 times 3 square root of 2. Well, the two radical pieces get multiplied together, and that gives me a 3 times the square root of 24. And the 24 can be factored. I could factor it as 12 times 2, but that doesn't really help. It's going to work better to factor it as 4 times 6, because the 4 we see is a perfect square. And so that pops out and becomes a 2, and we end up with 6 out front, the 2 times 3, and a 6 underneath. So 6 square root of 6 is the answer. Here's another example. 3 times the square root of 15 times 4 times the square root of 21. Well, I don't know off the top of my head what 15 times 21 is. When I multiply these together, I'm going to have the 3 times 4 is 12, and I'm going to have these multiplied together under a radical. It's going to be easier, though, to factor them first. So let's rewrite the problem like this. I'll put my 3 and my 4 together out front, and that gives me a 3 times 4. You could go ahead and write that as 12. Then underneath, instead of 15 here, I'm going to write 3 times 5. And instead of the 21, I'll write 3 times 7. And now look here, this 3 and this 3, those could be thought of as a 3 squared. I could just rearrange these factors to put those 3's next to each other and have a 3 squared. And a 3 squared underneath the radical is the same as a 3 out front. So those two together are, think of it as a 9 under the radical, 3 times 3. That pops out front as another 3 out there. So out front I have my 3 times my 12 right there. So outside of the radical I get a 36, and then underneath the radical I have 5 times 7, which is 35. So 36 times the square root of 35 is the answer. Here's another example, square root of 20 times the square root of 55. And again, this one's going to be easier if I just factor these two first. So the square root of 20 is the square root of 4 times 5. And the square root of 55 is the square root of 11 times 5. Now the 4, that's easy. The 4 is going to come out front here. It's gone from under the radical, and it's a 2 out front. And then I have, underneath the radical, I still have 5 times 11 times 5. And look at these two 5's. That's a 5 squared under the radical. You can think of it as 2 5s, or as a 5 squared, or as a 25. Either way, when we square root it, if that's a 5 squared, when we square root it, both of those guys are going to be gone from under the radical, and that's equivalent to a 5 out in front of the radical. So we have a 5 times 2 out front, which is a 10, and an 11 underneath the radical. So 10 times the square root of 11 is the answer. And that would commonly be read as 10 root 11. Here's another example, and what we'll see here is that the same concepts apply even when variables are involved. We've got the x under here and here. So let's work this out. Again, this is going to be a little bit easier if we go ahead and factor these. So let's write the problem as 4 times the square root of 2 times 3 times x times, and then our second product, or our second factor here, is 3 times 5 times x. Okay, all of those things can be thought of as being under one radical. And I'll go ahead and write that step, although it's pretty easy to do this next step mentally here, but you could imagine these as all being under one radical. 2 times 3 times x times 3 times 5 times x. And then hopefully you can see what can happen. This 3 times 3, just rearrange those so the 3's are next to each other. That's a 3 squared. Those guys go away and pop out front as a 3. And that's not 34 right there. That's 3 times 4. And the same thing happens to these x's. That's an x squared. It pops out as a single x. Remember, this is the square root of the x squared. So it becomes an x out front. So what we have now, out front I have an x and a 3 times 4. That's a 12x out here. And then underneath the radical I have this 2 and this 5. That gives me a 10. So 12x times the square root of 10 is the answer. And here's another example. 2 times the square root of 3a cubed times 3 times the square root of 6a squared. Okay, let's rearrange things and factor some things in the process. This 2 times the 3, I'm just going to combine those as a 6, and then I have my 3a cubed. I'm going to write that as 3 times a squared times a. So that's that radical, and then I also have this radical, and that's going to be the square root. I'm going to write the 6 as 2 times 3, and then I have the a squared. Now let's think of all the perfect square factors that can be removed. Well, there's an a squared, so I'll cross it out here. Instead of an a squared under the radical, I have an a outside of the radical. And the same thing happens here. That a squared goes away and becomes another a there. And then I also have a 3 here and a 3 here. That's equivalent to a 3 squared under the radical. And so if I strike those out, I can write a 3 out there outside of the radical. So that gives me out front here, have a 18, 6 times 3, and a squared. So I'll write 18a squared, and then underneath the radical I simply have an a and a 2. So I have a square root of 2a, and that's my answer. 18a squared times the square root of 2a, and it's simplified because all the perfect square factors that can be removed from under the radical have been removed, and they've been combined out front into this 18a squared.